You guys, welcome back. So today again we will be starting the new question of blind 75. Okay, blind 75 lead code, right? So as you all know, this is one of the most important 75 question series on DSA in Python. So most of the product based companies are asking such questions on day-to-day basis, and we need to grasp the concept. Okay, so we need to practice it, and we need to see what can be the brute force approach, what can be the optimal, what can be the super optimal approach. Okay, how can we reduce the time complexity from order of n square to order of n, right? So let's pick another question. So let's do this valid parenthesis and merge to sorted list. Then we will go for merge k sorted list. Okay. Can we do linked list cycle? It's an easy one. So before that, we need to see what linked list is. Okay. Let's try doing linked list cycle. So first of all, let's search what is linked list. Okay. So linked list is a fundamental data structure where elements called nodes are stored. Okay, nodes are stored non-contiguously in memory. Okay, each node contains actual data and a pointer. Okay, reference to the next node in the sequence. It allows dynamic memory allocation and in and efficient insertion or deletion without shifting elements. Okay, so let's understand what's geeks for geeks. Say, so uh, this is from Geeks for Geeks. Okay, so a linked list is a fundamental data structure in computer science. It mainly allows efficient insertion and deletion operations. Okay, compared to arrays. All right, like arrays, it is also used to implement other data structures like stacks, queues, and DQ. A linked list is a type of linear data structure. Individual items are not necessarily at contiguous location. All right, so the individual items will not be at contiguous location. Okay, that's the linked list. It's linear data structure. Yes, the individual items are called nodes and connected with each other using links. Okay, so these individual items, okay, these are called nodes, and these are connected with each other using links. Okay, so this is node, and address pointer. Okay, this is the link. Okay, and last node of the linked list points to the null. Okay, last node will be null. A node contains two things. First is data and second is a link. Okay, so the node has two things. One is data and one is link that connects it to another node. The first node is called the head node, and we can traverse the whole. So this is the head node, and we can traverse the whole list using this head and next links. So through this is the link. This is again, these are the data, and these are the address points. So one node has the data and their address and link. All right. So is the comparison of linked list and array. So what are linked lists? So we need to compare what is the advantage of using linked list or what is the disadvantage. Okay. So we have linked list, and we have this data structures. In the linked list, the data structures are not contiguous. Memory allocation. So here typically allocated one by one to individual elements. As you can see here, for this head node, we have this address. For this node, we have this address, right? Address pointer of the next node. Okay. So this is the address of the next node. Okay. This is the address of the next node. So here it is 4000. So it is the address of this next node. Okay. This is the linked list. That is why we call it as linked list. Okay. So this is a node and this is the address, but this address is not of this node. This address is of this node. All right. This address is of this node. That's the concept of linked list. All right. And it is typically allocated one by one to individual elements. Yes. Insertion deletion is efficient. So whenever we do insertion or deletion in an array, we have to shift all the elements, okay, as per the position of the inserted elements, right? But here insertion deletion is very efficient. We will look into what insertion and deletion in linked list is. All right, so here is the comparison. In array, data structure is contiguous. Here data structure is not contiguous. Memory allocation. So in array, the memory is allocated to the whole array, okay. And as I told you, insertion or deletion takes time complexity. Worst case is order of n, okay. So you have to shift each and every element, okay. So the time complexity is more. That is why this is array is inefficient, okay. And access is random, okay. Now there are different kinds of linked list. Let's go through one by one, and we will do some easy problems here only, okay. And there are a lot of problems, hard problems, easy problems, right? So we can look them one by one, okay. Okay. So singly linked list is a structures. It consists of node where each node contains a data field, okay, and a reference to the next node, okay. So I'll just paste the link here. So a singly linked list is a fundamental data structure. It consists of nodes where each node contains a data field, right? Each node will have a data field and a reference to the next node in linked list, as I told you. Okay, this is called a singly linked list because it has only a single access points, right? The next, the next of the last node is null. Why it is null? Because it should be null because the address uh, column which it pertains to the next node is nil, right? So there is no next node. That is why the address of the last uh, node has to be null, indicating the end of the list, right? So it indicates the end of the list, right? It will end the list. Linked list supports efficient insertion and deletion operations. So in arrays, we used to do a lot of operations in inserting or deleting any element, but in this linked list you have a lot of, I mean, you have efficient ways wherein you can insert or delete certain elements in a linked list, right? So let us try to understand what is node structure, okay. So in singly linked list, each node consists of two parts, right? Data and pointer to next node. So this one is data and this will be pointed to next node. So here it will be address of the next node. So the structure allows nodes to be dynamically linked together, forming a chain like sequence. So you can see here, this is the chain like sequence. This is the node structure. So if anyone asks you what is the node structure of singly linked list, then you should tell them it is a chain like sequence, right? It is a chain like sequence wherein the uh, node consists of two parts. One is data and one is the pointer to next node, right? The pointer to next node. So instead of that address, you can just tell it's a pointer to next node. So one is data and one is pointer to next node. So what is the node structure? It is a chain like sequence where each node consists of two parts, data and pointer to next node. So this is how you present it nicely to the interviewer, right? Now the definition of node, it is a singly linked list, yes. So how you can represent it using a code, okay. So the data part of node will be self dot data is equal to data and self dot next is equal to none, right? So this is the data part of the node, right? So in this example, the node class contains an integer data field, data, right? So this is the integer field. So we have the class node, then we will initiate a def function init, where we will be giving the inputs as self and data, right? So the data will be the input, okay. And this is to store the information and a pointer to another node, right? So this is the integer data and this is the pointer to another node next, right? So this will be the next node to establish the link the next node in the list, right? So this is the structure, okay. So creating an example linked list of size 3 to understand the working. So see uh, let's create size 3 to understand how it works. So let us first create the first node. So allocate memory for first node, store data into it, mark this node as head, right? Then we'll create the second node, allocate the memory of second node and store data into it, right? Link the first node to the next to this new node, right? So we have to link first nodes next to this new node, right? Then we'll create the third node, we'll allocate memory for third nodes and store the data in it, and we will link the second nodes to the next of this node, right? And we will set the next to null to ensure that the next of last is null, yes. So uh, when we see that there is an end of the elements in the linked list, then we will just put the next to null, right? So simply we have self dot data is equal to new data, self dot next is equal to none, right? And we'll create the first node. So head is equal to node, we'll assume it as 10, okay. Will link to next node will be head dot next is equal to node of 20. So it means that this is the head and we have assumed this node as 10 number node, and the next node will correspond to node 20. So this is how we link the second node. Then head dot net next is equal to node 30. So this will create the third node, okay. And this is how we create the first node. So how you can print the linked list? We'll just store the value of head into temp, and we'll assume a while loop. We'll start a while loop, and we will we will give the condition if the temp is not none, then it will start printing the temp data, okay. And we'll get this output 10, 20, 30, 40. So this is how you create the nodes. Okay. So while temp is not none, okay, so it means that we are considering the temp has the value head, and till the time it is not none, then it will print the temp data, right? And we'll create a space, and temp is equal to temp dot next. Okay, so it will iterate again and again. So this is the output will be like this. Now what are common list? So there are several operations. So first is traversal, then second is insertion, deletion, searching, updating, and reversal, right? So in traversal of singly linked list, you have one of the fundamental operation where we traverse or visit each of the linked list in this article, right? So we will cover how to traverse all the nodes of singly linked list along with with its implementation, right? So you have this head, and you will traverse like this. Okay, so output will be 1 2 3 4 5. Okay, because these are the um, contents in the head, right? Every element of each node from head to last node is printed, which means we have traversed each node successfully. So whenever we need to print all the elements in the node like this. So how is the step-by-step algorithm? We will initialize a temporary pointer to the head node, right? So we have to initiate or initialize the temporary pointer. Okay, after that we will check if that pointer is null or not null, right? Right? We have to check whether the pointer is null or not null. If it is null, then we need to return, right? Then we'll return. While the pointer is not null, we will access and print the data of the current node. Then we move to pointer to the next node. So this is how we'll print. Okay, we'll define. We will initiate a def function. We'll give new data. Okay, cell dot new data. Cell dot next is equal to none. So it will see when this none is coming. Okay. Now we will traverse. So let's define a traverse list. Okay, where we give the input as head, and we will traverse till the head is not none. Okay, we have head dot data, and if head dot next is not none, then it will print. We'll print the arrow, and head is equal to head dot next. So this is the important condition. If head dot next is not none, right? So as soon as it is none, it will not print this. It will not print this. So this is another example. You create a hard coded linked list 10, 20, 30, 40, right? So head is equal to node of 10, head dot next is equal to node of 20, this is node of 30, this is node of 40. Now we will see the function. We will just put this head in the traverse list, okay? And we have this list. We have all provided that node till node 40, it is not null, right? So it will traverse. This function will traverse one by one, okay? So till node 40 it will get print. Once it searches for node 50, so it finds that there is nothing, it is null, so it doesn't print this. It doesn't print this. That is why we don't find an arrow after 40, right? So talking about time complexity, okay, this is n will be the time complexity, and space will require is order of 1, because we are not using any extra space, we are just using the space which is already provided, okay? So we have the space complexity as order of 1. Okay, now one more method, we can use recursion. Okay, recursion is a very nice technique where you just have to call function into function, right? And that will get uh, called one by one, and once that value is reached, null is reached, then it will stop and it will go back. It will go back, right? So this is called as recursion, and then it will print. So there can be two types of recursion also, okay? So we'll see it. So we start at the head of node of singly linked list, check if it's node, if it's null or not, and print its value, right? So we then call the traversal function again with the next node passed to pointer, right? So how is the algorithm? We define a recursive method to traverse the singly linked list, which takes node as parameter, right? In this function, the base case is that if the node is null, then we will return from recursive method. We then pass the head node as parameter to the function. After that, we access the print and the data of the current node. At last, we make recursive call to this function. So you can see here, function to traverse and print the single list. This is the similar thing. We will define this self dot next is equal to none, right? And we'll define traversal list. Okay. If head is none, then it will print and it will return. So this printing the current node will print the arrow if it is not the last node, right? Moving it to the node, right? So here also time complexity is order of n. And what space we are taking? Yes, we are taking here order of n because of recursive stack space. Okay, it will do recursion and it will use all the stack space at once, right? If we try to understand how insertion works, so insert a node at front of linked list. Let's say we want to insert this. This starts from 2. I need to insert I need to insert a new node at the beginning of the linked list, right? So we have this output. So we can see that one is inserted at the beginning of the linked list. Okay. So step one is inserting a node in front of linked list. Okay, so this is the new node, and we want to insert is in front of this. Okay, so second step is assign new node. Next is equal to head. So here we have to assign the address of this node. Okay, so what is the head becomes new node, new head, right? This it becomes, and then linked list after insertion. How is the algorithm? We'll define insert at front, head comma x. So head will be our head and x will be the new node. Okay, that will be node of x. New node is equal to node x. New node dot next is equal to head. So here you can see the time complexity becomes order of 1 in linked list. So whenever you insert, here we are inserting the node. What is the def print list? Then current is equal to head we will keep, while current is not none, right? Print will, what will print? Current data with that space, right? And if current dot next is not none, right? So it will print this. Otherwise, it will just do current dot next. Okay. So here is our head next, head next, head next. So up to node 5 we are given. Okay, so we'll insert new node. If we have x equals 1, then head equals insert at front. So this is the function we will call, insert at front. Will give the value of head and x. Okay, so head is there and x is there, and we have x equals 1. Okay, all here, node 3, node 4, node 5. So we get 1 2 3 4 5. Initially it was 2 3 4 5. Okay, so here we get the time complexity as order of 1, and in arrays we used to have time complexity as order of n, right? So this is the advantage of using linked list. So if we want to insert and then this is the linked list, we have this head, and here we want to insert the 6 number null, right? So inserting this new node, this is the process given. We have this constructor, we need to initialize the constructor. So we'll need to initialize a new node with data. So self dot data is equal to x, and self dot next equals none. Then given the head of list and an end, okay, we append a new node at the end and returns the head. So insert at end is the function we are calling, and we have this head and x, and creating a new node is equal to node of x. We just have to put the value of x, and we are good to go by calling this function. If head is none, return new node, right? If the linked list empty, make the new node as the head and return. While the last dot next is not none, then we'll update this last is equal to last dot next. Similar we are calling, and we have this value of x equals 6, and we get this out. We get the time complexity as order of n, where n is the length of linked list, right? So this is how we can insert the element in the beginning, in the end. Similarly, we can delete from beginning. So this is the head, and I want to delete this, so I get this. So what do I do? Deletion of first node. So here the time complexity is order of 1. What do you mean by doubly linked list? Let's see the theoretical part also. So doubly linked list is a more complex data structure than a single linked list, but it offers several advantages. The main advantage of doubly linked list is that it allows for efficient traversal of the list in both direction, right? It can go to both direction, right? So in data structure, a doubly linked list is introducing nodes that have three fields. Okay, the first one is data, second to the next node, and a pointer to the previous node, like this. So this is the previous node, this is the next node, this will have address of the previous node, this will have address of the next node, and this is the data to store the value. How do we represent it? So simply we have to uh, initiate a def function where we give the data as the input, and to store the value we have self.data, reference to the previous node, self.prev is equal to none, self.next is equal to none. So this is how, this is for previous and this is for next. So this is the doubly linked list in Python. How do we represent it in Python? Okay, so each node in a doubly linked list contains the data it holds, pointer to the next node in the list and pointer to the previous node in the list, right? By linking these nodes together through the next and previous pointers, we can traverse the list in both directions, right? This is a key feature of doubly linked list. So we can traverse it forward as well as backward. This is the most important advantage of using the doubly linked list. How to create a doubly linked list with four: create a head node, allocate a node, and set heads to it. Its previous and next node should be null. Create the next node and head dot next is equal to new, that will be the node value. Head dot previous is equal to head. You can create further nodes in the same way. This is how you do it. And this is the representation of the doubly linked list, right? Let's see the theoretical aspect of circular linked list. So a circular linked list is a data structure where the last node points back to the first node, right? Forming a closed loop. All nodes are connected in a circle, enabling continuous traversal without encountering null. Okay, so here null will not be there. So the last node in a circular linked list will point to the first node. So it is ideal for tasks like scheduling and managing playlists where smooth and repeated action is required. Okay, in circular singly linked list, each node has just one pointer called the next pointer. circular singly linked list. Each node has just one pointer. It will be the next pointer. Because this result in forming circle types of linked list. We can only move through the list in one direction. And what about doubly linked list? In circular doubly linked list, each node has two pointers, previous and next, similar to doubly linked list. The previous pointer points to the previous node and next points to the next node. Here, in addition to the last node storing the address of the first node, the first node will also store the address of the last node. Alright. We will use single linked list to explain the working of. So what are the advantages? There are no null pointers. Okay. Insertion or beginning or end is order of 1. There is a uniform traversal and efficient memory utilization. What is the disadvantage? Complex implementation, infinite loop risk, yes. Harder to debug. Deletion complexity is there. Memory overhead or doubly linked list. No cache friendly. Okay. So these are the different advantages and disadvantages of using the linked list, circular linked list.